Hey, Sophie Airlines Math and History, and we are going to be simplifying the square roots. So, when you think of a square root, you probably learned about this symbol right here. And you probably also learned that if you put a number like 16, you try to find what number can be multiplied by itself twice that could get you to 16. Well, 4 times 4 is 16, so the square root of 16 should be 4. That is easy to simplify. However, sometimes you'll come across square roots that don't really work well. Like, how do you find the square root of 20? Well, the thing is, 20 is actually not a perfect square. Because what number times itself 2 times will bring you to 20? Nothing. So, we'll have to take another step of simplifying it. So, if we try using this as an example, like the square root of 16 is an even square root, and you can simplify it easily, what happens if you try to apply the same rule with this one, but we do it in another way? Like, we have to do it in the same step, but advance it further. Why can't we say 4 times 5 will bring you to 20, but the square root of 4 and the square root of 5? Because when you have a square root and a square root, and you try and multiply them, you will get to a whole number. So, basically, 4 times 5 is 20, but since 4 is an even perfect square root that you can actually pull something out of it, you can turn it into a 2. Cross that out. The thing is, 5, however, cannot be simplified. And since we haven't used it yet, we have to pull it way over here. So we have 2 to the square root of 5. We rationalized it, and we made it more simpler. Now it's more easier to calculate than a super long decimal like 1.6198561811. So basically, that would take forever to calculate. And usually, when you find an irregular square root or a square root that doesn't go in easily to be simplified like this one, you'll have a decimal that will go on forever and ever and ever. There was one more scenario that we're gonna learn about. Imagine we have the same kind of problem once again, but we have a 3 or a whole number right in front of it. Well, we have to ignore the 3 and apply the same steps as last time. Square root of 4 and the square root of 5. Since 4 can be pulled out, we can put it into a 2. Cross it out since we already used it. But since we have 2, that's a whole number, and since 3 is a whole number, we have to move the 2 and the 3 and multiply them each other, because they're whole numbers. So now we have 6 to the power, 6 times the square root of 5, because we haven't used that 5 yet. So 6 to the square root of 5 is a more simpler version or more easier way to calculate than this. But why do we choose 4 and 5? Why can't we just choose 2 and 10? Well, 1, 2, and 10 are not perfect squares, or at least one of them are not perfect squares. When you try to find the perfect square of something like 72, you'll want to find 2 numbers that can both go into 72. That's 1 is a square, and 1 is the greatest common factor. So we can do 12 and 6, but none work because neither of them are squares, or square roots. If we say 9 and 8, we can definitely do that. So, when it comes to if it's an irrational square root, or you can't easily do it, try to come up with numbers that have a square root that can go into, and the greatest common factor, biggest number possible. And that is the scenarios of how we can simplify the square roots. I hope this video has helped you. Thank you for watching Taoping Airlines Math Industry. Like and subscribe.
Hey you, stop right there.